Hey, hello everyone. Welcome to our YouTube channel. Today we will discuss the topic quadratic equation class 10 mathematics. In this lecture we will discuss an important concept from the lesson quadratic equation. So we know that any equation that can be written in the form ax square plus bx plus c equals to 0 is called a quadratic equation, where a, b, c are real numbers and a is not equals to 0. Why a is not equals to 0? If a becomes 0, then it will remain a linear equation in variable x. So therefore a is not equals to 0. For example, we can say equation 3x square plus 5x minus 2 equals to 0 is a quadratic equation in variable x. So here variable can be any x, y, z, small English alphabets. Take any variable. The next concept to check whether the following equations are quadratic or not. So consider first example. Here I can see equation x minus 2 bracket square plus 1 equals to 2x minus 3. After simplification, using identity a minus b bracket square, using the identity a minus b bracket square equals to a square minus 2ab plus b square, we get x square minus 4x plus 4 plus 1 equals to 2x minus 3. After simplification and taking terms on the LHS, we get x square minus 4x minus 2x plus 5 plus 3 equals to 0. Adding like terms together, we get x square minus 6x plus 8 equals to 0. So it is in the form x square plus bx plus c equals to 0. Hence it is a quadratic equation. We can say that this equation is a quadratic equation. In the same manner, if we solve second equation, which is x into x plus 1 plus 8 equals to x plus 2 multiplied by x minus 2. So once we simplify, what we will get here, x into x, x square, x into 1 x plus 8 equals to product x into x, x square, or you can use the identity a plus b, a minus b, which is a square minus b square. So x square minus 2 square, 2 square is 4. After cancelling x square on both sides, or that terms will get cancelled from both sides, we get x plus 8 equals to minus 4, x plus 8 plus 4 equals to 0, x plus 12 equals to 0. Now here degree 2 term of variable x is absent. So this is not a quadratic equation. This is not a quadratic equation. Let us go to the next example, number 3. X multiplied by 2x plus 3 equals to x square plus 1. So after simplification, we get 2x square plus 3x equals to x square plus 1. Taking terms on LHS, x square minus 2x square minus x square plus 3x minus 1 equals to 0, which equals 2x square minus x square is x square plus 3x minus 1 is equals to 0, and this is of the type x square plus bx plus c equals to 0. So is a quadratic equation. This is a quadratic equation. Now let this last four example I will keep for you. You try and tell answer in the comment box. Let us go to the next question. Formation of quadratic equation when sum and product of roots are given. Now for the equation ax square plus bx plus c equals to 0. The quadratic equation has two roots, say alpha and beta. Then the sum of roots alpha plus beta is minus b upon a, which we studied in the chapter polynomials, and product of roots product of roots, that is alpha into beta, is c upon a, constant term divided by coefficient of x square. So if these values are given, how we can find quadratic equation? So we can find quadratic equation using the formula as we studied in the polynomials. It is equals to x square minus alpha plus beta x plus alpha beta is equals to 0. So sometimes in exam we have given sum of the roots and product of roots. Sum and the product of roots, and we have to find equation. So suppose we have given sum 2 and the product 4. To find out equation using this formula, so we will have equation x square minus 2x plus 4 equals to 0. Suppose sum of the roots is 1 upon 2 and the product of roots is 1 by 4. Then the equation is x square minus sum of the roots minus half x plus 1 upon 4 equals to 0. And after multiplying by 4, we will get 4x square minus 4x square minus 2x plus 1 equals to 0. So in this way we can find out the quadratic equation whose sum and the product of roots is given. Sometimes only roots are given, alpha and beta. So if only alpha comma beta are given, then we will solve sum first, addition of that two roots, and then product, and we will apply this equation, find out quadratic equation. So I hope concept is clear. Let us go to the solution of quadratic equation by factorization method. So consider first example, x square plus 11x plus 30 equals to 0. So as we studied earlier in chapter polynomials, to find out roots, we do the product of coefficient of x square and constant term. So here it is 1 into 30 equals 30, and we factorize 30 as a product of two numbers such that their sum is equals to the coefficient of middle term. And here coefficient of middle term is 11. So I can say 30 can be factorized as plus 5 and plus 6. 6 5s are 30 and their addition is 11. So we can write this middle term as 5x plus 6x plus 30 equals to 0. And then taking common terms, we get factorization as x into x plus 5 plus 6 into x plus 5 equals to 0. So first factor is x plus 5, which is common, and the second factor is x plus 6 is equals to 0. So either x plus 5 is 0 or x plus 6 is equals to 0. So we get x equals to minus 5 or x is equals to minus 6. So these are the roots of given quadratic equation. So there is also a shortcut way. Once we find out factorization, we change the sign of this middle term and then divide it by the coefficient of x square. So these values are directly the roots of equation. You can use this trick while solving MCQs. Now second example. In second quadratic equation, x square plus 18x plus 32 equals to 0. Product of first term coefficient and the constant term is 32, and to split it as a sum of two numbers we can write it as plus 2 and plus 16, as 16 twos are 32 and 16 plus 2 is 18. So again in the same manner we will write the middle term as 2x plus 16x plus 32 is equals to 0. Now taking things common, we get here x into x plus 2 plus 16 into x plus 2 equals to 0. So which is same as x plus 2 multiplied by x plus 16 equals to 0. And then finally, after equating both factors equals to 0, we get first 0 as x equals to minus 2 and the second 0 as x equals to minus 16. So I left these three examples, remaining three example to you. You can solve and answer in comment box. Now let us go to the next concept, which is very important and many times in exam question is asked on this concept, nature of roots. So now we know that any quadratic equation has two roots if it is solvable. It will have two roots, say alpha and beta. If it is possible to find roots, it will have two roots. Then these roots may be real and distinct. They may be real or equal, or sometimes the roots of quadratic equation does not exist. Now for this quadratic equation, the value d equals to b square minus 4ac is called as, this value called as discriminant of quadratic equation. This is called as discriminant. And depending on value of discriminant, the roots are nature of the roots is decided. So if we solve value of discriminant and that value is positive, greater than 0 means positive. So the roots are real and distinct. The roots are real and distinct. Again, if the value of d is perfect square, means we can take the exact square root, then the roots will be rational roots. The roots will be rational if d is a perfect square. We can take square root if d is perfect square, and if d is not perfect square, then the roots are irrational roots. Then the roots are irrational roots. We will discuss in next section what are the roots. But just remember here, if the value of discriminant is positive, then the roots are real and distinct. We get different roots. The roots are rational if d is perfect square, and the roots are irrational if d is not a perfect square. The next condition, second condition, if value of d is 0, then this quadratic equation will have real and equal roots. Real and equal roots, and that roots are always rational. That roots are always rational. Now third condition, if value of d is less than 0, negative value, then the roots are complex. These numbers we will study in higher classes, grade 11th. So this is not for our study. In simple way, we say no real roots exist. No real roots exist. So there are three possible ways. First, if discriminant is positive greater than 0, the equation has real and distinct roots. Again, in that if D is perfect square, if D is perfect square, the roots are rational. And if D is not perfect square, the roots are irrational. If D is equals to 0, roots are real and equal and that are rational roots. And if value of discriminant is negative, so we cannot take a square root. So the roots are complex roots. So we say no real roots exist. I hope this chart is clear to you. This is a very important topic. The next topic is quadratic formula. So for this equation to find out roots, as we discussed, the b square minus 4ac called discriminant, and depending on that, the nature of roots is decided either real and distinct, real and equal, and the third case, no real roots. So in third case, we will have no roots. So how roots are find out? The formula to find out roots of quadratic equation is x equals to minus b plus minus root of b square minus 4ac divided by 2a, and this formula is called as a quadratic formula. This formula is called as quadratic formula. Let us solve some examples using this quadratic formula. Consider the example equation 2x square minus 7x minus 15 equals to 0. For this equation, we have a equals to 2, b equals to minus 7, c equals to minus 15. First, to decide nature of roots, we will solve discriminant, and that is b square minus 4ac minus 7 square minus 4, a is 2, c is minus 15. So minus 7 square, square always positive, 49. Then minus minus plus, 15 8s are 120. Sum is 169, which is positive. It means we will get a real and distinct roots. We will get a real and distinct roots. That roots are given by the quadratic formula as we discussed earlier. X equals to minus b plus minus root of b square minus 4ac divided by 2. Replacing values, we will get minus minus 7 plus minus value of discriminant, which is equals to 169 divided by 2 into 2. So it is plus 7 plus minus root of 169, so that is 13 square divided by 4. So we get 7 plus minus 13 upon 4. So there are two possible solutions. One is positive, one is negative. So 7 plus 13 is 20 upon 4, that is 5. And 7 minus 13 is minus 6 upon 4, that is minus 3 by 2. So the possible roots of equation are plus 5 and minus 3 by 2. So in this way you can solve other examples. This is how we can use the quadratic formula and decide the nature of roots. So I think all concepts are clear. So in this video we have discussed about the quadratic equation, the equation which is of the type ax square plus bx plus c equals to 0, a not equals to 0 called quadratic equation. Then we have solved some example where we check the equation are quadratic or not. In next topic we discuss about how to find quadratic equation when sum and the product of roots is given. The next topic we discuss solution by factorization method, the nature of roots depending on value of discriminant, and at last we studied quadratic formula and solving quadratic equation using this quadrant. Thanks for watching. Please like, share and subscribe, and do comment your queries in the comment box. Thank you.